Do we have questions about OpenMP, or maybe I'm interested to hear about the unified memory that you presented or you mentioned about University of Tsukuba.
Yeah. So that I'm very especially and personally studying this in GH200. So there are both an AMD MI300A and the NVIDIA GH200 ready for the shared address space between the CPU and GPU, but the architecture is totally different. So the GH200 is some extension from their traditional way of the HBM for GPU and the DDR for CPU. But here is a new hardware technology, NVLink C2C, which connects that both sides with about 450 gigabytes per second. And this is about 7 times faster than the traditional PCI Express Gen 5. And over this NVLink C2C, they finally established complete shared address space. But the uniqueness of this one is not just an shared address space access with each other. So when the GPU, Hopper GPU is accessing to the DDR memory so frequently, it is automatically transferred or migrated to the HBM memory. Then after that, this data is perfectly with a high throughput access by the GPU. So it is an underground, So that, for example, many users just allocate the memory at first touch manner in the DDR memory, but it is automatically migrated to the GPU HBM memory when it is so frequently accessed to the GPU. It is very interesting feature, but NVIDIA says about that technology, but no detailed data or algorithm or how much frequency is required to transfer the data perfectly. Everything is unbuilt. So my team makes everything is built and kind of the reverse engineering to find out. And we found that about 50 to 100 times of each page access makes a complete migration. On the other hand, AMD has a perfect flat HBM solution. Both the CPU and the GPU share the same HBM. So we think that this is some kind of ideal. So for example, Bronis in the Livermore, of course, he's supporting the AMD GPU. He said that it is very beautiful and good, but I think we found that some bottleneck by the CPU access sometimes interfere the HBM access from the GPU. So the characteristics of the memory access is totally different in the two systems. So that is very interesting for us as a researcher, but then we need to some care about how allocate and how touch based on the memory behavior difference.
And NVIDIA is the sole manufacturer. I mean, it's all NVIDIA stuff, or they integrate something on that?
Oh, it's just an NVIDIA stuff, everything.
Okay.
So that, then NVIDIA is the biggest company for the supercomputing now. They have a great CPU. They have a Hopper or a Blackwell and the next generation GPU. And not just that, they also have an InfiniBand technology. They bought a Mellanox. So the NVIDIA can construct everything by themselves. So the first, the governmental program contacted the NVIDIA of how about coupling of the NVIDIA's GPU and the Fujitsu CPU. So perhaps, this is my guess, but they answered, why Fujitsu? We have everything. But that is not suited for the national project. So that finally the NVIDIA and the Fujitsu shake hands to make a coupling system.
Right. So let's start with Chris from Cambridge University.
Thanks, Taisuke, for the talk. I've got a question about the GPU educational resources. Mm-hmm. So it's good that we're going to have a non-vendor, vendor-neutral, GPU vendor-neutral source of GPU education. What's the licensing going to be on those materials? Would it be openly licensed so that somebody could make a translation sort of out of Japanese?
You mean the license to use the machine?
No, license to use the educational materials, the videos, the teaching.
Okay, thank you for the question. So that at first, education GPU resources and not requiring so big amount of the node hour. This is just for the education, not for the production level run. And performance tuning for the GPU single level, and maybe there are some multiple GPU level. But anyway, we allow them just the testing and their tuning and also learning. So under HPCI program, so if they have a HPCI account, everyone can access all the HPCI resources. But we just focus on our 3 core universities GPU system, and also we strictly limit the resource usage because these machines are shared by the much more larger of the node hour for all the productive run of the science. And we are now discussing with NVIDIA and the AMD of the translation method. But actually, so NVIDIA people say that they want to translate our own material. At this moment, it's already existing. And they say that how about using the AI translator to distribute these materials? So NVIDIA is so enthusiastic about AI translation from Japanese version to English version. And I didn't tell detail, but we have some plan to share these materials with the world, maybe center by center or something, like UK and US and everywhere where the GPU is running. And of course, you don't need to get the HPCI account at that time. But maybe we have some special contract with a director or a representative of the centers to share our materials. So HPCI account requirement is just within the Japan because it is not just a permission, but also we like to promote the HPCI users in Japan so much rather than yesterday.
Yeah, thank you for your interesting talk. The combination OpenMP and education is very near and dear to me. I'm in the board of directors of the OpenMP organization. And one of the things I'd like to do is take that a step further, including development of materials. So at SC26, I plan to have some activity around it. I definitely would like to talk with you about that because there's so many things in common that we can share. And mutually, not only us, but the wider group can benefit from each other. So if you have some time, I'd like to have a chat with you about that.
Okay, thank you. And actually, some relation with that two of the topics we are now challenging. One is in University of Tsukuba for the semi-automatic translation between the OpenMP target and the OpenACC with each other. And second one is University of Tokyo, maybe, here is Solomon, sorry for Japanese. But Solomon is a shared common platform is kind of the abstract level of the directives, which can be translated both to the OpenACC and the OpenMP target. And only the Solomon coding is required based on the some C++ manner. And then it is run on the both sides of the systems. So we think still the AMD is not a big major like NVIDIA. But then in these days, AMD's machine is also increasing their installation. So we think that the both side is a very important target. So we are very care about the relationship of the two languages, two GPUs, or two companies to contribute to the Japanese GPU computing.
Jeff, here.
Yeah, I had a question about this concept of made with Japan and actually creating the tools and such. For instance, in Australia, there's big installations of both AMD and NVIDIA. Are you looking to other countries to partner with in some of the education and developing some of the tools and materials?
Yes, absolutely, absolutely. And we are very interested into have any international collaboration to share their GPU materials or technologies. And that is one of the big mission of my head desk. So that please contact me at any time with maybe center level, we can share anything which we can share, okay? So that, for example, the code exporting or code importing is a very important mission of us. And one of them, I skipped the talk, but one of the small mission of the HereDesk is supporting the container technology for the older application developers in Japan. So they basically want to do the science. They don't want to do the coding. So, but they write the code. Of course, they need it. But then, for example, they are not so much have an effort about making a container system or to easy to export of the applications. And so that we will support them. So if they give us the code, finally we will make some container to be appropriately run on their many other systems. And that's on also for their importing. And material of the GPU education and the application program, which is developed under support of the HereDesk, is always exchangeable. The only problem is that some application people team is not like to open their source code. So I think that container is one of the solutions, or that without any open source version. But I strongly suggest to the government in the next stage, every governmental supported program should be open source for their science and society.
Eric, in the back.
Yes, on the education front, what are the domains or topics that are the most challenging for students to learn? And how do we help new people get on board and learn about the technology?
So of course, the first target is the scientific research. But also, as well as the scientific research coding, we also teaching that and how to use the AI, especially generative AI, for their general solution. And we are focusing on their AI coding of using the generative AI. And it's actually very, very improved nowadays. For example, the chat HPC in the Oak Ridge National Laboratory is a very interesting project. So maybe I misunderstood the question, but the student is as well as ordinary teaching to the student like a C, C++, Python or something. Now the OpenACC and the OpenP target is a new language to learn for the next step of the GPU computing, both for the science and the society. Does it make sense?
Thank you very much. And we hopefully will welcome you and your hairdress.
Okay. Thank you very much. Finally, I came.
And you will be back, I hope so.
Okay. Thank you very much.
Thank you very much.